In graphing these basic parabolas, the first thing to know is when the number in front of the x squared is positive, you're going to have a u opening up. This one here, I don't see a number, but there's a negative in front, which is -1. So if there's a negative number in front of x squared, then the parabola is going to open down like this one. Every time you graph a parabola, the very first point that you want to plot is the vertex. And something that we can use here as a shortcut is addition and subtraction is what moves a graph up, down, right, left. In this equation, I do not see any addition or subtraction. The same thing here, I don't see any addition and subtraction. So what that tells me is the vertex is going to be located at 0, 0. So I'm going to go ahead and in both of these put in my vertex at 0, 0 for both of them. Okay, so I have my vertex, which is right here and right here. Next, I'm going to plot 2 points on both sides of the vertex just to get how wide it is. When we get to that point, you can pick any number that you would like for x, substitute it in, and then find your y, plot your point. But I recommend staying very close to the vertex so that the numbers don't get too big and it goes off your graph paper. So if this is at 0, 0, picking numbers really close to 0, let's go ahead and maybe pick 1. So if I select 1, then I'm going to come over here, and in my original equation, 2x squared, notice I put a set of parentheses where the x used to be, and then let's take that 1 and put it right there. Order of operation dictates that we're going to do the exponents first and then the multiplication. So 1 squared, 1 times 1 is 1, and then 1 times 2 is 2. So we've got an answer of 2 when we substituted 1. So I have the coordinate 1, 2. So I'm going to use one of these points I have up here, and I'm going to plot that point, right 1, up 2. Okay, next I'm going to do just one more point, and so I'm going to select 2. I'm going to go into my original equation, 2x squared. Let's replace the x with 2. Following order of operations, I'm going to do the exponents before multiplication. 2 squared is 4, and 4 times 2 is 8. So I've got 8 when I substituted 2. So my coordinate is 2, 8. Let's go ahead and graph 2, 8. So write 2, up 1, 2, 3, 4, 5, 6, 7, 8. We're going to get 2 for 1. It's kind of like buy one, get one free, because we know that there is a line of symmetry. There's an imaginary line that cuts that in half. So if I have a point here and I'm 1 away from the y-axis that's cutting this parabola in half, then I'm going to go 1 away on the other side. Similarly, right here, if this point is to this direction, then I'm going to go ahead and move it to this way using that symmetry. And so I now have the graph of my parabola. Okay, so let's go ahead and do one more here. This one next to it. One more time, I did not see addition and subtraction, so that means my vertex was at 0, 0. Let's pick some numbers close to 0. So I'm going to go with 2 and 1 and 2. If I substitute 1 into this equation, I have negative, a set of parentheses squared. So I'm going to substitute in 1. Be careful if you do decide to plug in a negative number that you don't accidentally think negative is positive. This is -1 multiplied by the answer to 1 squared. So 1 squared, 1 times 1 is 1, multiplied by the -1 out front is -1. So I plugged in 1, I got out -1. So let's plot that point, write 1, down 1. Okay, substituting in the value of 2 into my equation. So negative x squared, replacing this x with 2. Order of operations, exponents first. 2 squared, 2 multiplied by 2 is 4. Multiplied by the negative 1 out front gives me negative 4. So let's plot the point 2, comma, negative 4. Right 1, 2, down 1, 2, 3, 4. Okay, then using the idea that we've got symmetry there, we've got this U that's going to open down. So if I have a point located right here, then I'm going to move, that's 1 away from the line of symmetry there. So I'm going to put that one there. And then this guy here, okay, if it's 2 this way, it's going to be 2 this way. So there is my parabola. I'm going to do just one more here with some fractions that are involved. So in this particular problem, I again do not see any addition or subtraction. So the first thing I'm going to do is place the vertex, make that a little bit bigger. I'm going to place that vertex at 0, 0. And then I need a couple more points. 1 seems like a nice number because it's small. So if I substitute 1 into this equation, 1/4 x squared, my 1, that means the same thing as 1/4 times 1 times 1. 1/4 times 1 is 1/4. 1/4 times 1 is 1/4. So I end up getting out 1/4. Okay, and then just a recommendation, if you have an equation with fractions, substituting in a number that is divisible by the denominator, then your final answers will be whole numbers. So in this case, my denominator is 4. So if I substitute 4, that would be a good option, or 8 because 4 fits into 8, or 12 because 4 fits into 12. But I'm going to go ahead and substitute 4. So let's go ahead and do that. So replacing the x with 4, we end up with 1/4 times 4. Remember, when you multiply a number by a fraction, you're really dividing by the bottom and multiplying by the top. So 4 divided by 4 is 1, and 1 times 1 is 1. So 1/4 times 4 is 1, and then 1 times 4 is 4. Okay, so I substituted 4, and I got out 4. So let's go ahead and plot these points. Right 1, up 1/4. So right 1, up 1/4, which is not up very high there. And then right 4, up 4. Right 1, 2, 3, 4, 1, 2, 3, 4. So there's another point. And now I want to go ahead and reflect that across that line of symmetry. So I'm 1, 2, 3, 4. So 1, 2, 3, 4. So there's a point. Okay, and then here I was right 1, up 1/4. So I'm going to go back 1, up 1/4. Now that I have a few points, I can sketch in this parabola. It's not surprising that it is opening up because the number 1/4 was positive. Quick recap, remember, if you don't see addition and subtraction, then your vertex immediately goes at 0, 0. And then you're just going to pick a couple of numbers that are close to 0, substitute them in to get a couple extra points. Use that symmetry so that you kind of buy one, get one free.